Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 26, Episode 48, for broadcast on the 21st of April, 2023. Coming up on SpaceTime, an ancient white dwarf star in a planetary graveyard. A new study shows that Einstein was right, again. And Russia shows off its new weapon of mass destruction. Behold, the Satan II. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered one of the oldest planetary graveyards in the Milky Way. The observations, reported in the monthly notices of the Royal Astronomical Society, are providing scientists with a glimpse of our own end-of-the-world fate when our sun becomes a white dwarf in around 7 billion years from now. The planetary corpses are orbiting around an ancient white dwarf star some 91 light-years away. The 10 billion-year-old white dwarf is slowly cooling, and it's developed a reddish hue, polluted by lots of rocky planetary debris. Most stars, including our Sun, will end their life as white dwarfs. It goes like this. Stars shine by fusing hydrogen in their core, eventually producing helium. When these stars run out of hydrogen, hydrostatic equilibrium, that is the balancing act between the outwards push of nuclear energy and the inwards push of gravity, ceases, and gravity wins, causing the star's core to dramatically contract and compress under its own enormous gravity. As the star contracts, regions around the stellar core which still contain hydrogen move closer to the core and therefore closer to the region where pressures and temperatures allow hydrogen fusion to take place. And this triggers hydrogen burning in a shell around the core. And that causes the star's outer layers to dramatically expand. And now being further away from the core, the star's photosphere, or visible surface, is cooler than it was, and so it looks redder. The star, now called a red giant, experiences a massive increase in its stellar wind production as more and more material flows out from its gaseous envelope. Meanwhile, back in the center of the star, the increase in temperature and pressure caused by the core collapsing and contracting eventually triggers what's called helium flash, fusing the core helium into carbon and oxygen. Now, high-mass stars, those much larger and heavier than the Sun, will progressively fuse heavier and heavier elements, repeating the same process. But smaller stars like the Sun don't contain enough mass to fuse carbon and oxygen into heavier elements, and so stellar fusion ultimately ends, and the star dies. The star's outer gaseous envelope drifts away as a spectacular planetary nebula, leaving exposed the super-dense white-hot stellar core, a white dwarf which will slowly cool over the eons of time. In trillions of years' time, it'll cool down enough to become a black dwarf, but the universe hasn't been around long enough for that to have happened to any white dwarf yet. The atmospheres of white dwarfs are mainly composed of hydrogen and helium, but between 25 and 50% of all known white dwarfs also contain traces of metals in their spectra. Now, astronomers refer to all elements heavier than hydrogen and helium as metals. These metals originate through the accretion of tidally disrupted planets that were previously orbiting the progenitor star but were consumed as their host star expanded into a bloated red giant. In this new study, astronomers from the University of York used data from the European Space Agency's Gaia spacecraft to identify two white dwarfs which displayed both unusual colours and brightnesses. Follow-up spectroscopic observations made with a very large telescope in Chile and with the Dark Energy Survey showed that one of these white dwarfs, catalogued as WDJ 2147-4035, was unusually red and appears to be the coolest and faintest white dwarf ever seen. The other, catalogued as WDJ 1922+0233, has a bluer hue, but is still the second coolest white dwarf ever detected. And by observing the chemical composition of material in the atmospheres of the white dwarfs, astronomers have been able to infer the composition of the planets destroyed by the stars. They say that WDJ 2147-4035 provided astronomers with a snapshot of what the galaxy was like 10 billion years ago, while the other white dwarf, WDJ 1922+0233, gives us all a glimpse of what the galaxy was like 9 billion years ago. Jonathan Nally, the editor of Australian Sky and Telescope magazine, says the study's authors found that the debris falling onto the bluish-hued white dwarf star has a composition similar to that of the Earth's continental crust, while it seems the reddish white dwarf's planets were about 1 billion years older and contained unusually high amounts of potassium and lithium.
A polluted white dwarf, that's what some astronomers have been studying. A white dwarf is the remnant core of a large star that's left over when the star goes through its death throes. Our sun will do this. It'll eventually swell up and puff off its outer gas layers and leaving just a white dwarf behind, very, very small compared to the normal size of the star. And it's just this hot, small remnant star core, which will then just slowly cool down. When a star does go through its death throes, and it swells up and puffs off its gas layers and things, it can disrupt and break up any planets that are orbiting too close. Ones that are much further out, they might survive, but ones that are closer in, like Earth, when our sun does it, we're not going to survive. So what you end up with is a whole lot of planetary debris orbiting this white dwarf and eventually falling down onto its surface. And this is where they get the term polluted white dwarf. It's not made of pristine white dwarf stuff anymore. It's got rocky rubble and stuff that's falling down and getting onto its surface. So they can tell this when they look at a white dwarf. They can look at the spectrum and they can tell that this white dwarf is polluted because they can see in the spectrum different stuff that you would normally expect to see. Yeah. Old car tyres, that's right. Old copies of Australian Sky and Telescope magazine, that kind of thing, yeah. So in this particular research we're talking about, a team led by a UK scientist have taken a close look at 2 polluted white dwarfs. They used the European Southern Observatory's Very Large Telescope, the imaginatively named Very Large Telescope in Chile, and another instrument also in Chile called the Dark Energy Camera, which belongs to the Cerro Tololo Inter-American Observatory. Now, one of these white dwarfs that they've been studying is the reddest they've ever seen in our galaxy, and the other one is bluer rather than red. The red one, they have calculated, must have formed more than 10 billion years ago. All right, so this is a star that puffed off its layers and everything and left this remnant core 10 billion years ago, and this core has been slowly cooling down ever since. The other one, the bluer one, is about 9 billion years old, they reckon. And both of them are considered cool in a temperature sense. And temperature is what the scientists use to estimate their age. They use theory to determine how hot a white dwarf should be when it sort of first is uncovered, when the original star puffs off all its gas and stuff and just leaves the core. So they can then calculate how hot it should be then. And then by comparing it to how hot they measure it to be now, they can work out how many years it's been cooling down. So the cooler they are, the longer they've been cooling down. As for the pollution of this planetary debris, well, this can tell astronomers something about those planets or maybe asteroids and things that were circling the star before it ended its life and that are now formed this debris that's falling down onto the white dwarf. So using spectral analysis, they found that the debris falling onto the bluer star is actually chemically pretty similar to the rocks in Earth's crust. So that's an interesting indication that maybe there was a planet there that was pretty similar to Earth's, at least in chemical makeup. The other one is a bit of an unexplained oddity because it has much more potassium and lithium than they would have expected to see. I don't know especially what that means in terms of what could have been there. Maybe there were lots of asteroids or something that had those particular chemicals in them, or a planet that had a lot of potassium. Who knows? But anyway, it's definitely there. The thing is, though, I still marvel at the modern astronomical technology that can give us this sort of detailed information about tiny celestial bodies that are, in this case, I think one is 91 light years away, the other one's 300-something light years away, and they can tell you what the chemical makeup is of the stuff that made up the planets or asteroids or whatever that originally circled this star and has now been destroyed and is falling onto the White Dwarf. It's just staggering. I mean, this stuff was just unimaginable decades ago. So we really do live in exciting times in the sense of being able to do this sort of work and just makes your mind boggle as to what's going to come up next.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. Still to come, a new study shows that Einstein was right again, and the Kremlin shows off its newest weapons of mass destruction. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
There's an old saying in physics, it never pays to argue against the great Albert Einstein. Now, new maps of the universe's cosmic growth are proving that to be true yet again, providing support for Professor Einstein's theory of gravity. For millennia, humans have been fascinated by the mysteries of the cosmos. Unlike ancient philosophers, imagining the universe's origins on the shell of a tortoise supported by elephants, modern-day astronomers and cosmologists use quantitative tools to gain insights into the universe's evolution and structure. Modern cosmology dates back to the early 20th century, with the development of Dr. Einstein's theory of general relativity. Now, researchers from the Atacama Cosmology Telescope collaboration have created a groundbreaking new image that reveals the most detailed map of dark matter distribution across a quarter of the entire sky, extending deep into the cosmos. Dark matter is a mysterious and invisible substance that makes up some 85% of all the matter in the universe. Scientists know dark matter is real because they can see its impact on the rest of the universe. It provides the extra mass gravity needs to prevent galaxies from flinging themselves apart as they rotate, and it provides the gravitational lensing effect needed to amplify distant background objects by bending their light. But it also means that everything we know, from the biggest stars, gas clouds and planets, down to cars, houses, people, trees, and the smallest grains of sand on the beach, accounts for less than 15% of all the material that makes up the universe. But despite making up the vast majority of the universe and influencing its entire evolution, dark matter has been hard to detect because it doesn't interact with light or any other forms of electromagnetic radiation. As far as we know, dark matter only interacts with gravity. This new study confirms Einstein's theory of how massive structures grow and bend light over the entire 13.82 billion year lifespan of the universe. The new study's lead author, Blake Sherwin from the University of Cambridge, says the new map displays invisible dark matter across the sky out to the largest distances, and it clearly shows features of this invisible world that are hundreds of millions of light years across. To track it down, more than 160 scientists gathered data from the National Science Foundation's Atacama Cosmology Telescope in the high Chilean Andes. They observed the light emanating following the dawn of the universe's formation, the Big Bang, a time when the cosmos was only 380,000 years old. Cosmologists often refer to this diffuse light which fills our entire universe as the first baby pictures of the universe. But formally, it's known as the cosmic microwave background radiation. The authors tracked how the gravitational pull of large heavy structures, including dark matter, warps the cosmic microwave background radiation on its 13.82 billion year journey to us, in exactly the same way as a magnifying glass bends light as it passes through its lens. So the new mass map is using distortions of light left over from the Big Bang. Remarkably, it provides measurements that show that both the lumpiness of the universe and the rate at which it's growing after almost 14 billion years of evolution are exactly what you'd expect from our standard model of cosmology based on Einstein's theory of gravity. Schoen says the results also provide some new insights into an ongoing debate which some scientists have called the crisis in cosmology. This crisis stems from recent measurements which have used two different sources to try and achieve the same result. One used background light from cosmic distance markers in order to determine cosmic distances. The other used the cosmic microwave background radiation. And the results they've come up with from the two different sources are very different. And as we get more precise, they're not coming closer together, they're moving further apart. The findings have produced results that suggest dark matter wasn't lumpy enough under the standard model of cosmology and led to concerns that the model may be broken. However, the team's latest results were able to precisely assess that the vast lumps seen in the image are exactly the right size. So it's going to be fascinating to see how these different results are eventually resolved. This is SpaceTime. Still to come, Russia's new secret weapon of mass destruction, and later in the science report, the massive bird of prey that once called Australia home. All that and more still to come on SpaceTime. As the Kremlin's war against Ukraine drags on into a second bloody year, and the planet now teeters on the precipice of a third world war, this one with nuclear weapons, Russia has conducted what it says is a successful test launch of its new advanced intercontinental ballistic missile. The test flight came just weeks after Moscow suspended participation in its last remaining nuclear arms control treaty with the United States. The Russian Defense Ministry says the test saw a combat crew successfully launch the RS-28 Zermatt, or Satan II ICBM, from a mobile launcher in the Caspian Yar test site. The missile's training warhead then reportedly successfully hit its target at a training ground thousands of kilometers away in Kazakhstan. The 36-metre-tall three-stage liquid-fueled missile is capable of carrying a 10-ton payload over a distance of 18,000 kilometres. The launch vehicle has a short boost phase, which lessens the interval when it can be tracked by satellites with infrared sensors, thereby making it more difficult to intercept. Satan II can be equipped with either 10 heavy or 15 light, multiple independently targeted thermonuclear reentry vehicle warheads, or up to 24 avant-garde hypersonic glide vehicles, giving it a range of 35,000 kilometres in suborbital flight. Since first sending his troops into Ukraine last year, Russian President Vladimir Putin has continually issued thinly veiled warnings that he might use nuclear weapons. Then in February this year, Putin suspended participation in the New START treaty, under which Russia and the United States both agreed to limit their nuclear stockpiles and submit to mutual inspections. As of April 2023, the Federation of American Scientists estimates that there are some 12,500 nuclear warheads in existence. Roughly 9,576 of these are in military stockpiles for use by missiles, aircraft, ships and submarines. The remaining warheads have been retired but are still relatively intact and are awaiting dismantlement. Of the 9,576 warheads in military stockpiles, some 3,804 are deployed with operational forces either on missiles or in bomber bases. Now, of those, approximately 2,000 US, Russian, British and French warheads are on high alert, ready for use at short notice. Current estimated global nuclear warhead inventories suggest Russia has some 5,889 thermonuclear warheads, and that number is growing by the day. The United States has some 5,244 nuclear warheads. China has 410, but you can expect that to reach well over 1,000 by 2030. France is 290, the United Kingdom 225, Pakistan 170 and growing, India 164 and growing, and North Korea 30 and growing. Now, Israel never comments on its nuclear forces, but current best estimates suggest that Jerusalem has at least 210 thermonuclear warheads available. And then there's Iran, vigorously claiming to be innocent, but still working on its own nuclear warheads program, with help from their allies North Korea, who only a few years ago also claimed to have no interest in developing thermonuclear weapons. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that people who start using cannabis at an early age, or those who use a lot of it, tend to be worse at learning from their past mistakes. The findings, reported in the journal PLOS One, are based on a study of 70 people, 36 of whom were chronic cannabis users. The researchers found those who started using the drug at a young age and those who used it the most were worse at learning from and correcting errors in a computer-based task than non-users and those who started using drugs later in life or used it more moderately. The task presents participants with letters on the screen and then asks them to press a button for each letter unless the same letter is presented twice in a row, in which case they're not to press the button. If they failed and pressed the button anyway, they were told to press a different button following the appearance of the next non-identical letter sequence. Analysing the data, they found those who started using cannabis younger or were the heaviest users performed worse at recognising mistakes or following the procedure to correct the error. Paleontologists say the skies of southern Australia once played host to a massive bird of prey that was twice the size of the modern-day apex predator, the wedge-tailed eagle. The new research from Flinders University shows the ancient eagle, which soared the skies more than 60,000 years ago, had a wingspan of more than 3 metres and powerful talons large enough to grab a big kangaroo. A report in the Journal of Ophthalmology describes Dinatoatus graphi as the largest bird of prey ever to live on the continent, and probably the largest continental eagle in the world. Closely related to Old World vultures of Africa and Asia, and the critically endangered monkey-eating Philippine eagle, the now extinct raptor was the top avian predator during the late Pleistocene. Scientists have detected dramatic global thermospheric disturbances caused by last year's Tonga volcanic eruption. The findings, reported in the journal Geophysical Research Letters, shows the impact of the volcanic eruption were felt at altitudes up to 500 kilometres above the planet. That's higher than the orbit of the International Space Station. The authors found the Tonga volcanic eruption significantly redistributed the global neural density 500 kilometres above the ground, with higher density in the antipode hemisphere on the opposite side of the planet to the eruption, and lower density in the volcanic eruptions hemisphere. The researchers discovered that this eruption stimulated thermospheric-atmospheric fluctuations with multiple wave modes in a speed range between 200 and 450 metres per second. The thermospheric-atmospheric fluctuations propagated globally in concentric circles centered on the Tonga volcano, and some of the wave models can propagate and converge to the antipode of the volcano, and then further diverge from the antipode to continue propagation. The researchers believe that in accordance with the characteristics of propagation, thermosphere-atmospheric fluctuations may be related to the upward transmission of energy from gravitational waves, LAM waves, and tsunami waves in the lower atmosphere. A lot of weird things are going on in the White House. Apparently, there have been ongoing reported sightings of no one less than former President Abraham Lincoln, or at least his ghost, haunting the building. It seems White House staffers first began seeing the deceased president's ghost walking the halls of the residence in the days immediately following his assassination. First Lady Grace Coolidge claims she saw Lincoln's ghost staring across the Potomac out of a window in the Lincoln bedroom. And President Ronald Reagan's dog often stopped to bark at the Lincoln bedroom and refused to go inside the room during his time at the White House. Tim Mendham from Australian Skeptics says Lincoln's ghost has reportedly been seen in the White House by more than a dozen world leaders, including British Prime Minister Sir Winston Churchill.
There are supposedly various stories of Abraham Lincoln appearing, looking wandly out the window of a room in the White House, or wandering the corridors, or apparently disturbing Winston Churchill when he just got out of a bath, totally naked but with a cigar. It's just an interesting thought when Churchill was visiting during the Second World War. And the interesting thing is, what I ask is, why is he haunting the White House? He was there in the White House for about 5 years. You know, he was there for one term and a little bit more. There's been 8 presidents who have died in office, American presidents who have died in office. 4 of those were assassinated. And Lincoln was the first, but there has been 3 after, up to Kennedy. Why aren't they haunting the White House as well? Why don't you have, do you have to be assassinated, or can you just die in office, which would mean there'd be 8 presidential ghosts wandering around the corridors of the White House? You'd hardly miss them after a while.
Wouldn't Lincoln's ghost be hanging around where he was killed?
That's the other thing. There was where he was shot, which was the Ford Theatre, and he was taken to another building, the Peterson House. And both the theatre and this house are about a kilometre away from the White House. So would he be haunting the Peterson House, which is still there, or would he be haunting the Ford Theatre, where he didn't die, but he was shot? So traumatic place, death place, place of work. Or why wouldn't he go back to where he grew up in the first place and return to Springfield? Not where the Simpsons are, but Springfield, Illinois. So why hasn't he gone home? Why the White House? And because he was a president, obviously. That's why he's in the White House. So that's where he had his most fun times. He certainly had traumatic times in the White House when his son died at a young age. His wife sort of went over the edge a bit and got involved in all sorts of spiritualism to try and contact their son, etc. And he apparently took part in a couple of little seances or whatever they were at the time. But that doesn't mean he's coming back as a ghost. And there's all sorts of questions. But of course, people don't bother about that. It's just Lincoln, who's an identifiable-looking person. He's handy. If you were coming back as James A. Garfield or William McKinley, would you know what they look like? Would you recognise Warren Harding if you met him in a bar? No, because they look very ordinary-looking sort of people, whereas Lincoln's tall, beard, all that sort of stuff. So he's easily identifiable. So there's all those sort of questions. Is Kennedy's ghost in the White House or in Dallas or wherever? Who knows? It's pretty shonky, pretty dodgy. Have people seen Lincoln? Have they thought they've seen Lincoln? It's probably the better question. And is it just fun for some people?
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.